Hello students, once again welcome back to Misostudy video classes. As it is clear from this first slide that today we are going to discuss in this video CBSE pattern question exercise, and the chapter is not very important but it is very interesting also, that is kinetic theory of gases. During the discussion of you can say various topics of material properties, I specifically mentioned that about gases we will discuss these concepts separately, and that separate topic chapter is kinetic theory of gases. So already we completed the theoretical aspects in various videos. I hope you also revise those topics. So now you are equipped with enough you can say skills to understand these questions. Over here the pattern is going to be same. Fine. First I will explain 1, 2, 3, 4 and so on questions. Also I will mark the numbering pattern. Because from last so many videos we are providing these details with each and every chapter, so I hope now you are finding yourself in a better and comfortable position. So let's start this discussion. The topic is kinetic theory, and here comes your first question. It is 1 mark question as usual, question 1 and 2. Fine. Now what is meant by Boltzmann constant? Actually this term KB is very important. Fine. And calculate its value in SI unit. Sometimes they may ask you dimensional formula also, whether applicable or not. Fine. So how you can find out this KB, that is Boltzmann constant. So basically KB is nothing but R by N. Fine. And R is universal gas constant, PV is equal to mu RT, and N is that number, Avogadro's number. Fine. So let's put the values and we can find out the result of this. So after putting the values, I just write down after putting the values, KB is equal to 1.38 into 10 to the power minus 23 joule upon Kelvin. Fine. Over here some confusion may be in the minds of few students. What we will write down the meaning of Boltzmann constant? Simple. It's a constant introduced by the scientists and the value of the constant is this much. In 1 mark, what else you want to write down? Confine yourself so that you can use this time for long questions. Again and again I am explaining this strategy. Fine. So time saving that you will start learning over here, it's going to be very useful for you in your competitive exams also. So it is the answer of this particular question, that the Boltzmann constant value and its units. Fine. After mentioning this you will get 1 full mark. It comes question number 2. Now can the temperature of a gas be increased keeping its pressure and volume constant? Actually the reason behind putting these questions over here, to force you should think. Fine. And when you will start thinking? Only when you are comfortable with the basic concepts of this chapter, that is kinetic theory of gases, KTG. Once you are comfortable, then definitely these points will force you to think, even if you are walking, even if you are sitting idly watching TV or something like that, because these are so simple and very interesting aspects. Say for example, can the temperature of a gas be increased keeping its pressure and volume constant? The question is simple. The question is, it is asking any change, it is something that I am telling you, you need not to write down it, okay? Any change in temperature, fine, can the temperature of gas, any change in T possible without changing P or V. The question is like this. It means if we are putting pressure and volume of a gas fixed, is it possible for us to increase or decrease the temperature? Fine. This is the question basically. So what I did, I mentioned the question other way around. Now it's easier for you to understand. The answer is what does it mean? It means if you want to change the temperature of a gas, either P, either V or both will change. Actually, why it is so? The question comes in the mind. Fine. In answer, you have to only write down no, without changing P and V, we cannot change the temperature. The question that may come in your mind, why exactly it is so? Okay. So in order to understand various concepts of a gas, you need three coordinates. One is pressure, one is volume, another is temperature. Now, let's say in a container I have some gas. Fine. This is elaboration of this question. It is for 1 mark. You have to write down only 2 sentences which I mentioned. It is for your understanding, I am repeating. Let's say you have a cylindrical closed container and a gas is placed inside that. It is now completely tight. So volume is fixed, okay, pressure is fixed for the time being, temperature is fixed. Now as per the question, P constant, V constant and T is changing, okay. What exactly the simplest possible method with you? You should provide the heat energy from outside if you want to change the temperature, or you should extract out heat energy from that particular bottle. Moment you will provide heat energy or you will extract heat energy, what will happen? It will remain same, you can say okay, but what about the pressure? Pressure is what? Momentum transfer. Momentum transfer is what? Associated with root mean square velocity. So if temperature is increasing, V is increasing, V is directly proportional to, VRMS is directly proportional to this. Increase this, it will increase. If it will increase, try to recall this momentum. This pressure will enhance. Pressure is what? Hitting the walls of the container, that is pressure. Rate of momentum transfer, simple. So you can start thinking in this manner and then you can really visualize the outcome. Fine. Here this you can say point was just to give you some better understanding. Okay. Then students, it is question number 3. Now question number 3 and 4, 2 marks. Please be careful. Read the instructions carefully. On driving the scooter for a long time, the air pressure in the tire slightly increases. Why? Actually, my simple suggestion is, if anyone is driving the car or bike on any expressway, he or she should reduce the air pressure. Reason is simple. I will write down, but first listen. If you are driving on a road, obviously some friction is there, because without friction you cannot drive your car properly. So due to friction, fine, the work will be performed by the engine, and because of this friction, heat energy will be transferred. So heat energy is transferred, so what will happen? Pressure will increase. Rate of momentum, the same explanation which I used just 2 minutes back, that was VRMS is directly proportional to T, and VRMS is something which is associated with the momentum, and pressure is the rate of momentum transfer. That's it, simple. So the answer of this question, because it is for 2 marks, so at least you should write down 2 sentences. One sentence is, I am writing it as a point wise, while it is not like that it is true for a scooter, for any vehicle, fine. While driving any automobile, obviously on load, okay, due to friction, friction between tire and road. You need not to write down that much. I am giving you some enhanced information, you can use it selectively. While driving any automobile on road, due to friction between road and tire temperature increases, okay, so pressure. That's why from physics point of view, if you are driving your automobile from long time, like say 2 hours, 3 hours, then don't go for the pressure check process. The problem will be that the tire will not show exact pressure, so the gauge will not able to read the exact pressure. Fine. And if you are driving your vehicle in the season of you can say summers, and that too in daytime, that too in like conditions on an expressway or a tar road, first thing, reduce the tire pressure by 1 or 2 points, and never ever completely fill your this fuel tank. It should be around 20% blank. Fine. No, it's not like that. Sometimes I noticed people on the petrol pump or fuel stations, they love to put even a last drop in their this petrol or fuel tank. That is not advisable. Fine. So anyone studying physics is going to be definitely ahead with normal people. That's why physics is what? Study of laws of nature, and that's why this chapter is very important. It is question number 4, again for 2 marks, that is, explain the rise of temperature on heating on the basis of kinetic theory of gases. Now, if I am asking this question after question number 2 and 3, you yourself you can start writing down the answer, but because the question is there and I have to write down, so I will write down. But I hope the idea of pressure enhancement is clear in your mind. What is the question? Rise of temperature on heating. Explain the rise of temperature on heating on the basis of kinetic theory of gases. Okay. So the first answer, a student may say, sir, it is so simple. If I am providing heat energy, then temperature will increase. But the problem is different. Problem is this line, that is on the basis of kinetic theory of gases. Basically, you have to confine your answer. Fine. Otherwise, simply you can write so many things. But here the answer should be specifically keeping in mind the kinetic theory of gases. So you have to write down your answer only for gases. Fine. And that too with the assumptions of kinetic theory. Okay. So point wise what you can write down. Explain the rise of temperature. Of what? Of gas. Fine. When heat energy, just like a story, enjoy this story. When heat energy is provided, to a gaseous system, when heat energy is provided to a gaseous system, then I will talk in terms of VRMS. I think it is better. You can talk in terms of also temperature, but let's take the help of the known parameter. To a gaseous system, then root mean square velocity increases. You can say that is also associated with the temperature. Yes, both are correlated. Fine. System, then temperature, RMS root mean square value of velocity increases. You may say, sir, things are not clear. Heat energy we are providing, so temperature RMS value increases. What does it mean? Okay. So heat energy, fine. If heat energy we are providing, so try to recall what are the coordinates in which we would like to talk about this gaseous system: pressure, volume, temperature. So heat energy we are providing, fine, but it is enhancing the temperature of the gas. Then it is enhancing the pressure of the gas, rate of heating of the molecules on the walls of the container. Fine. So on the basis of this assumption, gaseous theory, kinetic theory, you have to confine your answer, and your you can say stick point should be this. Then you should talk in terms of energy conversion. Fine. Temperature is enhances. It is like that. Let's say I am asking you a question. You are coming to my home and I said, okay, I am going to prepare a tea for you. I have this steel utensil in which I am putting some milk and water, and then stove burner is on. So what will happen? You will say you are providing heat energy, so temperature of this liquid, that is milk and water, will increase. I will ask why? Because convection, conduction, what will happen? You know that. So similarly over here, these gaseous molecules getting energy, striking to the walls of the container, striking with each other, their temperature is increasing, their root mean square velocity is increasing. Simple. Fine. Now these type of questions are difficult from the point of view of scoring marks. Reason is simple. Why? Because of the reason that you don't know what exactly we should write down. If you are unable to confine your answer, then the probability is that you will not score full marks. But this question is in the category of 2 marks. So if you mention these terms, the examiner will not deduct any marks. There is an approach how you can score good marks. Fine. Then comes question number 5. And over here important aspect is now category changes. 3 marks. Fine. Over here, what exactly the problem? Obtain the relation between degrees of freedom of gas, okay, and ratio of 2 principal specific heats of the gas. Now this question is basically to check how comfortable you are, how efficient you are in driving these results. Fine. So what you can produce in this particular result? That is, basically first you have to confine your answer, because it is for 3 marks, so at least you have to mention terms, their names, their uses. Fine. And then relation. Directly don't jump onto the relation, it is not a numerical problem. Obtain relation between degrees of freedom. Degrees of freedom is for any gas, degrees of freedom given or represented by f or sometimes small n. Fine. Now degree of freedom means, I already explained you in our videos, that is, say for example monoatomic gas. So 3 degrees of freedom, x, y and z. For diatomic gas, translational these 3 and then 2 rotational. And for polyatomic gases, 1 vibrational mode is also applicable, so 6 degrees of freedom. Anyway, as per the confinement or specification of the gases, basically 3 degrees for monoatomic, for diatomic, for polyatomic, that is 3, 5 and 6. Okay. But here you have to mention a relation. Fine. Now 2 specific heats of gases are, actually when you are writing this answer you should do one thing. You should first mention this specific heat. Fine. So you can say there are two specific heats of a gas. Number one, Cp, then write down Cp is specific heat at constant pressure. Then number two, use different colors, pencils or pen, Cv, then write down like this, where Cv is specific heat at constant volume. Fine. Then Mayer formula, that already we discussed, that is Cp upon Cv is equal to gamma. What is gamma? Define, where gamma is the ratio of two specific heats, Cp upon Cv. Then Cp is what? Cv is what? If you are uncomfortable, my suggestion, please take a look of that particular video where I very specifically, very simply explained all this. Anyway, directly I am coming on to the relation. Why directly? Because already I explained it, and somehow with these questions I am forcing you, please go through with our previous videos. So this gamma is equal to 1 plus 2 by F. So basically this is the required relation, but this is not an exact answer. You have to write down like this. Wordings, because it is in 3 marks. Mention any gas has 3 degrees of freedom depending upon the nature of the gas. One is polyatomic, then it is diatomic, then it is monoatomic. So for monoatomic, 3 degrees of freedom, that is 3 translational possibilities. Then for this polyatomic, 6 degrees. Then for this diatomic, like that. Fine. So at least half page is required. Over here I am not writing all those things because already we discussed those things, you know, and it is still present with you in your videos also. Fine. So here comes question number 6, and the instruction of 3 mark is also equally applicable for question number 6, that is this one. Under what conditions of pressure and temperature a gas can be assumed as an ideal gas? Now, in simple terms, just one sentence is required, but here you should be very careful. Reason is, I can ask this question in 1 mark. Answer is going to be different. I can ask this question in 2 marks. Answer is different. Now this question is in 3 marks, so answer approach is different. I am just trying to show you the possibilities with one question. Depending upon the marks allocated, you have to enhance or reduce your answer. Fine. Now let's take a look over here. At what conditions of pressure and temperature a gas can be assumed as an ideal gas? First, read this line. All real gases up to some extent, this is the, you can say, crux of the matter. All real gases up to some extent, let me be very logical, all real gases up to some extent behaves as ideal gas at high temperature and low pressure. Okay. Now consider the situation. For 1 marks it is fine. Even for 2 marks, if you write this much, it is fine. But for 3 marks, it is not fine. After this, you have to define, and that's why this question in this 3 marks category. What you should mention? High temperature means what? For ideal gas, the assumption is the molecules of the gas collide with each other perfectly elastic. So if the temperature is high, the collision are going to be perfectly elastic in nature. Number 1. Number 2. Low pressure means what? Low pressure means the volume of the all molecules of the ideal gas is negligible comparatively to the volume of the container in which the gas is placed. So low pressure means very less number of molecules. So you can say in real gas terms also, the molecules volume or the volume of the molecules is really very small comparatively to the container volume. So you have to elaborate these points. I mean, that is on the basis of the assumptions of the real gas, ideal gases. Fine. So this answer is more than sufficient for this real gases behavior as an ideal gas. What is an ideal gas? Just few seconds back I mentioned. So you have to write down those assumptions. Ideal gas means molecules collide with each other in perfectly elastic fashion. They are perfect spheres. They don't you can say acquire any volume, or the volume of these molecules are almost negligible. Fine, 1, 2, 3, 4, 5. All these points I mentioned while I was discussing the theoretical aspect of this topic in our regular lectures. So you have to take a look of that. Mention its main characteristics. All these characteristics I explained. Yes, I am forcing you to revisit the videos provided by Misostudies to you. Fine. Here comes your question number 8, that is for 5 marks. Okay. Now this question is basically giving you another view of the same type of questions. Put aside all 7 questions till now we discussed. State the postulates of kinetic theory of gases, that ideal assumptions. Explain the pressure exerted by an ideal gas. At least 4 times in this video I mentioned momentum transfer to the walls of the container. That's it. So elaborate all those points which I explained you not only in today's video but also in our regular lecture. Fine. Perfect notes in terms of writing and explaining I already provided. In fact, I talked a lot about all these aspects in today's video in last 20-25 minutes or so. So let's move ahead. Over here, question number 9. Now 9 to 10 question is for 4 marks. Fine. Explain the concept of mean free path. Okay, 1 or 2 points I will mention, rest you know that it is already mentioned in this video. Gas molecules are always in random motion. So what? So they will collide with each other. The distance travelled by any molecule between 2 successive collisions. Again I am repeating. The distance travelled by any gas molecules between 2 successive collisions. That is defined as mean free path, lambda directly proportional to kT upon PD square, where terms have their usual meaning. This is Boltzmann constant with which I started today's lecture. It is temperature, it is pressure, and it is dia of the molecules. Fine. So this way in 4 marks you can write down the answer of this particular question. I am sure you have revised those videos because I specifically provided to these separate topics, and one topic is this, another was this. What is meant by Brownian motion? Even I explained that experiment also in my videos. What is that? It's a container. So n number of molecules are there. Fine. So basically the random motion of the gas molecules examined by a scientist, and then it is explained, and this explanation is defined as Brownian motion. You can also mention over here this mean free path. So these questions are not anyway difficult. Fine. And more important is, once you go through with this lecture, you need not to revise it. Everything is going to be over here because it is all practical. Even in this room in which I am shooting this video, I can explain this. So students, it was a collection of 10 very good, simple and interesting questions. I hope by combining your understanding of this topic from regular lectures, you will definitely provide correct and proper answers of these questions. By this method, if you are moving, definitely you will be able to score good marks. So I think we should stop over here. Okay, very soon I'll come back with some new videos. Till then, take care of yourself, keep revising. Thanks for watching the video.